Hi, my goal for this video is to get you really comfortable with the connection of finding the slope graphically and finding the slope with a formula. So we're going to look at just 4 examples. It'll move pretty quick, but I want to show you that they're one and the same thing. Finding the slope graphically as just counting between point and point, that actually works. And then finding the slope between point and point algebraically with the formula, it's the same stuff. Which one's easier? Kind of depends on what you're given. So in this little video, I'm giving you graphs, and I want to show you that you can quickly find the slope between any 2 points graphically. We'll also be doing it twice, so I'll show you how the formula also interplays. Let's check out our first, actually let's check out all the examples, because what I want you to do as you're working through this is look at what the slopes should be. So what do you think? Should we get a positive or a negative slope? You should know. Should we get a positive or negative slope? You should know. Should we get a positive or negative slope? Oh, crap. Should we get a positive or negative slope? That's even harder. We'll look at those because last video we talked a little bit about that in the last blurb. We'll look at why those numbers are the way they are, what the slope is for all 4 of those examples are why they are the way they are. The formula will show it to us. So let's check this out. Now, number one thing, as we're going to find slope here, we're always reading from what? As we read a book, from left to right. So when we're talking about vertical change, it's always predicated on the fact that we are moving from left to right. So we're not going to be counting, oh, I'm dropping from here to here. No. Since run always goes from left to right, our slope is always from left to right. So we're going to check this out. Here's how you can do slope very quickly just by counting between points. Count how much you go up. Slope is always rise over run. Always. We always talk about the rise. Then we always count that's from left to right as we go up or down. Then we compare that to the run as we move to the right. We can use a formula. We can do it directly from the graph. So how much do we climb from here to here? Just make a rectangle out of it. That's all we've got to do. It's a rectangular coordinate system. We would go up 1. Notice how we're starting from our left. We're going to the point on the left and in the point on the right. Up 1, 2, 3, 4. So we're climbing 4. We're moving up 4 spots as we move from left to right, as we go from point on the left to point on the right. That's cool. You know what that means? Our rise is 4. Write it down. 1, 2, 3, 4. Now, how much do we go to the right? Always to the right. If you move to the left right now, you're doing something wrong. Go back and fix your stuff. You should always be counting to the right. 1, 2, 3, 4, 5, 6. So we move up 4 and right 6. That's positive 4 moved up. Always positive because we're always going to the right with our run. That's 6. Our slope is 4/6. Does that look good to you? Now, because we're always simplifying fractions, can you simplify the slope? Absolutely. If you do, you're going to get 2/3. Now, what that means is that you can get to every other point by counting from any point to any other point by counting up 2 and over 3. That should work. Up 2, 1, 2, over 3, 1, 2, over 3 to the right. Up 2, over 3 to the right. Oh, that's cool. That's another point. Up 2, over 3 to the right. Up 2. You could continue forever. Now, I know there's an infinite number of points on that line, but to get from one point to any other point on this particular line, you would count up 2, rise of 2, over to the right 3, run of 3. That's it. Now, does the formula work the same way? That's what I really want to get you to, because in the next video, I don't give you graphs. I give you just the 2 points. Could you do it? Call one of those points x1, y1. Remember that the subscripts have to be the same. The first point says the first point. The second point says the second point. Call one point x1, y1. Call the other one x2, y2. Now, it doesn't matter which order you go in. And the reason why it doesn't, I get asked this a lot, well, wait a minute, if you're always going from left to right, don't you have to pick that one as x1, y1? Don't you have to pick that as x2, y2? If it makes you feel good at night, cool, yeah, do that, that's fine. But you don't have to. Here's why. The way that the slope formula works is it compares your up and down and your left and right no matter which points you call which. And here's why it does that. If I call this one x1, y1, and this one, x2, y2, the slope formula is going to work backwards. It would go to the left and it would count that as negative. That's why we don't do it, because it's confusing in our heads to go, well, I'm moving down and left, but that down part would not be negative. Rise is defined as being motion from left to right. So if we say, oh, we're going down and left, that's negative and, well, sorry, down motion and left, sure. But we'd have to make sure that we're saying negative, negative. That's what we have to be doing. And sometimes our brains don't do that. The slope formula does do that. So if we have positive up and positive right, that's the same as saying negative down and negative left. Can you do that? Yes, you can. The slope formula works that way. I don't like to teach that because students get very confused about it, but it does work mathematically. So be real careful when we're doing it on a graph. We're always going to go from left to right. That's how the run's defined. But the slope formula doesn't care. It will take care of your signs for you. Now, if you really want to just be double safe, I guess, call the point on the left x1, y1, call the point on the right x2, y2. That's what I'm going to do. So we're going to make sure that our x coordinates are being labeled as x coordinates and our y coordinates are being labeled as y coordinates, making sure that our 1s are together and our 2s are together. Now, let's just use the formula. But when you're using it, don't just take it for granted. Really understand what's going on here. If I want to find the rise, I want to find the distance on the y-axis. I want to find the difference between my y's. That's all you're doing. So here we have distance between the y's. Take your difference between the y's. 2 minus negative 2. Now that brings me to another point. If you're going to do this, you darn well better be using some parentheses and making sure that you're filling out your formula correctly. So our formula, our y's have to be on the top because that's what talks about vertical motion, that's the rise. I'm going to take my y2, I'm going to subtract. This formula always has minuses in it before you do any math. And that's, if you haven't ever heard me say this before, the way that you fill a formula out is you don't do any math in your head. You always start with how the formula looks. You always plug in numbers in parentheses, especially if they have negatives, because it's going to house the negative and maintain the operation. Don't outsmart yourself. It's easy to do by going, oh yeah, well, if I'm subtracting a negative, it's a plus, and then you put the plus, but then you put the negative anyway because you forget about it. Don't do that. It's a very easy way to make mistakes. So how I would do this is I would create some spots for my y2 and my y1. y2 is 2. y1 is negative 2. Notice how that it keeps the minus. It houses the negativity. It doesn't look real awkward, and it's exactly how the slope formula looks. I'm not doing any math in my head. The next one says, okay, go back to the point that you just started with. So we started with this point on the numerator. We've got to start with this point on the denominator. So 3 for my x2 minus negative 3. When I tell you to evaluate, that's what I mean. I mean for you to plug numbers into a formula, don't do any math in your head, and then slowly use order operations to work this thing out. That's how to avoid sign errors. One last thing, I mentioned this blurb in the last video. If you want to check your work, here's how to check your work. This looks weird, I'm going to look stranger than I normally do on this video, but do this. That should be a point. That should be one of the points on your graph. So this is the point 3, 2. Oh, hey, point 3, 2. This is the point negative 3, negative 2. Oh, negative 3, negative 2. I don't care what freaking order you put it in. As long as that works, you're going to be right. As long as you can do this, one point, another point, you have minuses between those, you're A-okay. That's how the slope formula works. Compares rise and run. So y's and x's, puts in order x, y, and it has 1 point, other point. That's it. Differences mean distances, so we're good. So take your calculators, do the math in your head. I don't care at this point. 2 minus negative 2 is 4. 3 minus negative 3 is 6. We simplify and get exactly the same slope that we thought we would. That's the idea. The formula works the same whether you're going to count or whether you're going to use math algebraically. It's kind of cool. Now, next one. Let's see if we can do this. See if you can count. As we move from left to right, so the point of the furthest left is here, furthest right is here. Let's count. Are we climbing Or are we falling to get from this point to here? It seems clear that we're falling. I didn't give you any indication of how far that is, so you have to look at the actual value. This is a height of 5. We're going to have to drop 5. 1, 2, 3, 4, 5. That's down 5. That's negative 5. Our rise here is negative. We're falling 5. Now to the right, right's always positive. We'd be going, well, it's negative 4. 1, 2, 3, 4, then another 5 spots. 5, 6, 7, 8, 9. So in total, 9 places. So we have negative 5/9. That should be our slope. We can't simplify it, but notice what it does. It tells us our slope is negative. We thought about that earlier. We should have a negative slope. Let's see if the formula works out. I'm going to go kind of quickly here on these ones. I would encourage you to stop and do them on your own. I'm going to call this x2, y2. It doesn't matter. It just seems right to me. I want the one on the right, x2, y2. This is x1, y1, no problem. Let's plug it in. So I'm going to start with this point. If you want to always do this, this is fine. Write out the formula with parentheses. That's a good way to do it. Just start plugging numbers in. Plug in the numbers, well, correct numbers in. Plug in your y's here and your x's here. Make sure this is from one point and this is from the other one, and you really can't get it wrong. Notice how I'm doing no math in my head. Could I? Yeah. Am I? No, because I don't want to make a mistake. 0, that's a y. 5, that's the other y. 5 for the x. Negative 4. I'm not even worried about the negative because I got parentheses plugged in. That's like a warm blanket. It's nice. And then I check. 5, 0 is one point. Negative 4, 5 is the other one. I have minuses between them, and I'm good to go. So 0 minus 5, hey, that's negative 5. 5 minus negative 4, same thing as saying 5 plus 4. You're going to get a lot of minus negatives in this formula. We get identically the same slope. It can't be otherwise. That's kind of cool. Now, how about the next one? What should that slope be? Just think about rise over run. As we move from left to right, how much do we rise? We don't. How much do we run? 1, 2, 3, 4, 5. We run 5 spots. We rise 0 spots. We do not climb from here to here. 0 change. Do we go to the right? Yes, we do. That's quantifiable. We go 1, 2, 3, 4, 5. How much is 0 over 5? Your calculator will tell you if you don't understand it. That's 0. You have a slope of 0. It says you climbed not at all as you move to the right. Our formula will tell us the same thing. Let's identify it first. Write out, if you haven't already, your x2, y2, and your x1, y1. Let's put them up here. Let's create the formula first with just some blank spaces like Taylor Swift, okay? Create a blank space right here. All you gotta do is create some blank spaces and write some names. It's like good old TS does, except our names aren't real names. They're values of numbers. There are y2, y1, x2, x1. If you want to do it differently, I sometimes do. Sometimes I do this, just change it up a bit. I'll just write a point here and a point here. Does it matter? Not really, but here's what I mean by that. If my x2, y2 is 3, 2, I'm just gonna look this way and write 3, 2. That's the same point as that, 3, 2. Cool. I'm going to look over here and write my point, negative 2, 2. That's another way that you can fill this out. It doesn't matter. As long as this is one point and this is the other one, and you have minuses between them, you're going to be right. These are y's, these are x's. You can do it this way also, the other way. y2 minus y1, cool. x2 minus x1 when I went back to the same starting point. Do some math. But we get the same thing. You're still going to get a slope of 0. Now the last one, probably the most confusing one for people. People also like to say that this has a slope of 0. Now in math, you're going to find this out if you don't know it already. If you have two different things, two different graphs that don't look anything alike, they're not going to have the same answer. So our slope of 0 is always horizontal. That means our vertical lines can't have a slope of 0. They have the reciprocal of a slope of 0. What's that mean? If you have a reciprocal, which means you flip over a fraction, if you have a slope of 0, 0 over a number, and you flip that around, you reciprocate it, you're going to have a number over 0. So a slope of 0 reciprocate the fraction for the slope of a vertical, you're divided by 0. You're going to get undefined. That has to have an undefined slope. Here's why. Check this out as the fraction. From here to here, as we go to the from left to right, which you can't do, so where are you going to start? I don't know. How far do you go up? 1, 2, 3, 4. You're climbing 4. From here to here, how much do you go to the right? And there it is. You can't divide by 0. If you want a little help on that, I'll give you it just after this. If you're like, why can't you divide by 0? If you've forgotten that, hang on for about a minute and we'll talk about that, why we can't do this. So this right here, that's undefined. You cannot divide a number by 0. We'd say slope is undefined. Now, what if you wanted to do it the other way? Which one's x1, y1, which one's x2, y2? It doesn't really matter, but because there's no point on the left, or the point on the right, there is no left or right, that should be your first indication that you're getting undefined. Let's call this one x1, y1, and this one x2, y2. Create a fraction. Let's put 1 point here. I'm going to create some parentheses, some blank spaces for us to plug some numbers into, our y2, y1, x2, x1. I'm going to write my first or my second point, it doesn't really matter, here. So -1, 2, and -1, -2. I know this is 1 point, x1, y1, or x2, y2. This is another point, x1, y1, and I have minus between them. No problem. You can go the other way, y2 minus y1, x2 minus x1, cool. But look at your numerator. Your numerator is not 0. Your numerator is 4. Your denominator is 0. That's the other undefined. Now, before I get into why that's undefined and why this is 0, I will in just a moment. Could you have done this if I didn't give you the graph? You don't even need to know what point is left or right. Your slope formula will do it for you. I talked about that earlier. It doesn't even matter. So if I erase the graph and just gave you the points, could you do it? If I just gave you the points, could you put them in the formula? If I just gave you the points, could you do this? Could you put these points in that formula? And the answer is yeah, clearly. We don't even need graphs. The only reason why this video exists is to show you that what you get graphically is what you get by the formula, in whatever order you put the points. That's kind of cool. So the next video, we just basically lose the line. Is it going to be quick? Yeah. It's basically just going to be doing this from 2 points. That's it. Now, for those of you who need a little hand with why this is okay and why that one's not, check this out. If you didn't know this about me, I love pizza. It's awesome. I like the frozen pizzas because I am cheap. And they have them on sale where I live for like $3.33 sometimes. So I stock up in a big chest freezer and it's freaking awesome. And we have pizza like at least 2 times a week. And it's delicious. And my heart sometimes goes, please, Leonard, please no more salt and fat. But I can't help it. It's so good. Now let's imagine that I take a pizza. And I cut this pizza into 4 slices. The amount of pieces that you cut something into is always your denominator. This would be a pizza cut into 4 pieces. Now let's say this. Could you cut a pizza into 4 pieces? Yes. And eat 0 of them? Could you eat 0 out of 4 pieces? Yes. It's called a diet. It's called self-control, something I've never managed. So anyway, yeah. So let's say you're serving the pizza, right? You cut it into 4 slices, you go, here you go. And they go, hey, have some. You go, nah, I'm okay. How many pieces have you had? 0. How much pizza have you eaten? None. You've eaten 0 pizza. That's exactly what this means. If you eat 0 out of 4 slices, you've had no pizza. That makes sense to say that. Now imagine the other one. Imagine 4 out of 0. Here's what this says. This says that you take your Easy Bake Oven, which doesn't have anything in it, and you go, I have no pizza. Here, have some. You, oh, I'd love 4 slices out of that no pizza. Can you do it? Well, if you're my 3-year-old daughter, it's called imagination. Yeah, fine. Diet, imagination. Diet, you eat no pizza. Imagination, this is trying to say, hey, take 0 pizza, have 4 slices. You can't even talk about that. You can't get 4 slices out of no pizza. For that reason, this is called undefined. You're asking a question that can't be answered, that you can't get anything from. You haven't had 0 pizza. That's where some people try to say, well, you've had 0. You still had no pizza. Well, yeah, I know, but this is assuming that you actually can. It's not imagination anymore. It's saying you got 4 pizzas. This is you actually ate it. You had 4 pieces out of 0, and you can't even get there. You don't even have enough pizza to make that. You don't have any pizza. You can't make it happen. That's the same idea on why that's undefined. I hope that clears up the fractions if you needed it. Next time we'll get back to our slope. We'll talk about slope between 2 points when we're not given a line. Hope it makes sense. I'll see you next time.